Welcome to the 3D Paradigm lecture series. And in this series, we will begin by developing a clear understanding of the greedy paradigm, its inner motivation, definition, some key properties, advantages, and limitations. Once the foundation is established, we will gradually move on to the design and analysis of some classic greedy algorithms, understanding not only how they work, but also why the greedy strategy succeeds for some problems and fails for others. And by the end of the series, you will be equipped to identify, design, and analyze some greedy solutions for a wide range of computational problems. To begin with, let us explore a few interesting real life examples that serve as analogies to the greedy paradigm. And these examples will help us to develop an intuitive understanding before we move on to the formal concepts. Imagine that you visit a shopping mall to buy a dress, and you have several shops to choose from. You enter the first one and see a dress that you like. Then in the next shop, you find a dress that looks even better. You immediately replace your previous choice with this one, which is quite expected. And as you continue shopping, whenever you find a dress that is better than your current favorite, you definitely update your choice. So by the end of your visit, you purchase the best dress you encountered. So what actually happened here? At every step, the best dress found so far, that will be treated as a current solution. And if the next shop has a better dress, you have replaced the current choice because you were greedy, so it can be treated as a greedy choice of yours. And you never keep up an inferior choice, so you always retain the best option seen up to that point. So this is very interesting analogy. Another very interesting analogy we have, suppose you go to a shop, it's the same type of analogy, to buy clothes, and the shopkeeper shows you some dresses. You notice that lady next to you has got a better dress in front of her. So why do I take example of a lady? Because as ladies have the core quality of jealousy packed in them, which is needed to get it to the situation I am going to explain now. So you, with all your smartness, apply some tactics. Make sure she doesn't buy that dress, and you, without much thinking, buy it. So, but just when you have paid your bill and are about to leave the shop, you see that the lady, the same one whom you outsmarted, has got a better dress than what you smartly have bought. So, since you have fixed budget, you cannot buy that dress now. So, you, in spite of all your perceived smartness, you are left with a suboptimal or very mediocre choice. So, what is the outcome of this analogy? This analogy captures a very important characteristics of our today's discussion, that is greedy algorithms. They make decision based on immediate or local information, and you do not evaluate all possible combinations or future consequences. And once a decision is made, it is typically not revisited. And therefore, in this paradigm, the algorithm is very fast and simple, but it does not always guarantee the globally optimal solution. Because I just told that in spite of all your perceived smartness, you are left with a very mediocre choice. So this is very interesting analogy of the greedy paradigm. Another very interesting analogy also I have. So assume that you get your kid the best possible education, and you want to get admission to a school for your kid. You go to the best pursuit school in the town. You pay them so-called hefty bribe, read building fund, charitable donation, whatever pleases you actually. Now, this school imposes too much of its rules on how kids should study and put in place a lot unnecessary crap. Suppose X day, Y day, gardening session, etc., etc., which is actually not imparting required knowledge to your child. Your kid reaches to fourth standard and even cannot multiply or divide to numbers reliably. So you see that your neighbor's kid who goes to a very ordinary school can easily do this. So you scratch your head, what went wrong that time? So the common thread running through all these analogies is the idea of making the best possible choice at each step. And this is precisely the essence of our today's discussion that is called greedy paradigm. And the greedy method actually suggests that one can devise a solution. One can devise a solution, or sorry, one can devise an algorithm, not a solution, rather, it is an algorithm that works in stages and considering one input at a time. And at each stage, a decision is made regarding whether a particular input is an optimal solution or not. And this is done by considering the inputs in an order determined by some selection procedure. And if the inclusion of the next input into the so-called partially constructed optimal solution will result in an infeasible solution, then the input is not added to the partial solution, otherwise it is added. So these are the very basic introduction of greedy strategy or the greedy paradigm. So I again repeat, the common thread running through all these analogies is basically the idea of making the best possible choice at each step. And this is the essence of our greedy paradigm. So if I go into the definition of the greedy paradigm, a greedy algorithm is an algorithmic paradigm that actually constructs a solution step by step by making the best possible choice at each stage according to a criterion that is called predefined criterion, and with the hope that these locally optimal choices will lead to a global optimal solution. So that is why in the slide it is written paradigm that constructs a solution step by making the best possible choice at each stage according to some predefined criteria, with the hope that these locally optimal choices will lead to a globally optimal solution. One thing that I must mention, that I have given the second analogy that was also related to visiting in a shopping mall and buy clothes, and where I told that in spite of all your purchase smartness, you are left with a mediocre choice. So, not every time the greedy algorithm, though it is first and simple, but it does not always guarantee the global optimal solution. But the principal objective of the greedy paradigm, from its definition, it can be stated that this is such a paradigm that constructs a solution step by step, definitely, by making the best possible choice at each stage according to some predefined criterion. So that is basically you are choosing some local optimal choices which will ultimately lead to you to reach to the global optimal solution. Okay. So once you are moving for or going through some of the chapters of the algorithm analysis, whether it may be greedy, whether it may be uh, divide and conquer, whatever it is, you must know the properties of those paradigms. So here we must know after definition, what are the properties of the greedy strategy. So the properties of the greedy strategy actually it begins with greedy choice property. So basically, a greedy algorithm makes the best immediate, which is actually termed as a local choice, at each step. And here, decisions are based only on the current state, and there is no future consequences are considered. So this is basically called greedy choice property. The second very interesting and very important property is the optimal substructure. An optimal solution to the problem, optimal means whether it may be a problem that is called maximization or minimization, you have to choose the best one. Whether it is a maximization problem or minimization problem, you have to pick up the best one, which is basically termed as an optimal solution to the problem that can be built from optimal solution to its subproblems. And in other words, we can say that solving the remaining smaller problem optimally helps build the optimal solution to the original problem. So this is basically the concept behind optimal substructure property. Another property that is step-by-step construction. It is actually quoted as when the solution is built incrementally. And in that case, you have one choice at a time. And each new decision extends the current partial solution. So this is called step-by-step constructions. And in case of greedy strategy, once a choice is made, it is never changed. Okay. And next one is local optimization. What does it mean? Each decision is locally optimal. It appears to be the best choice at that moment. And a greedy algorithm assumes that a sequence of such choices will produce a good overall solution. Another one, it does not always produce a global optimal. So that is why I told, in spite of your passive smartness, you are left out with a mediocre solution. So not every time your greedy property will be in favor of yours. So that is why it does not always produce a global optimum. What does it mean? A greedy strategy is not universally optimal basically, and it works correctly only for problems that satisfies both the greedy choice property and optimal substructure. Otherwise, it may produce a suboptimal, which is actually quoted as a mediocre solution. Apart from all those properties, the greedy algorithms are generally called very easy to understand, very easy to implement, and they are computationally very efficient. Okay, so this is about the properties of the greedy paradigm. So we will conclude our today's lecture by discussing one control abstraction for the subject paradigm. So here you will find that there is a structure given. The name of the in general uh, structure, it is called as a greedy structure. The algorithm is termed as a greedy one. That is basically reflecting the subset paradigm. Here we have taken two arguments. One is an array A, another is a number of inputs present into it. Here we are initializing the solution, which is initialized by phi. That is a solution is equal to, suppose it is 0 or like. And as there are n number of inputs, you are selecting one input at a time. From where? From the array A. So that is why it is written as a select. So here the function select actually selects an input from an array A, which comprises of n number of inputs. And once it is selected, it removes it. And the selected input value is assigned to where? Into a variable which is treated as an x. Second method, it is told if feasible solution comma x, then. So what does it mean? Here a new function comes that is by name feasible. It is actually defined as a Boolean valued function that determines whether x can be included into the solution vector or not. If it is a feasible, it returns a feasible solution, then that should be included, and inclusion is done with the help of a new block, new function that is called union. The function union actually combines the input x with the solution and updates the objective function. So it is basically update of the solution by combining the selected input, which actually results in feasible solution, with the way and updates the objective function. And once it is over, then you have to return the solution. So this is basically one of a very basic control abstraction of the subset paradigm that supports greedy. So, in conclusion, we can say that we are introducing the very introductory concept of the greedy paradigm. So, with this, we conclude our introduction to the greedy paradigm, and we have developed the intuition behind greedy thinking, understood its fundamental principles, and recognized both its strengths and limitations. So, in the upcoming presentations, we will build on this foundation by exploring some classic greedy algorithms and learning not only how they work, but also why the greedy strategy is optimal for certain problems. Thank you.